Alright guys, today we're going to talk about points, lines, and planes. Take notes over those. These are the basic terms of geometry, things that you really need to understand, sometimes referred to as undefined terms. So by the end of these notes, hopefully we understand about those. We can use them and build off of those terms. We're also going to talk about the basic postulates of geometry. We'll define postulates if you're in the dark on that. And that will set us up to be able to go through this geometry course. Today will be a lot of definitions, maybe a lot more so than normal. Make sure you feel free to pause the video whenever you need to in order to write down everything you need to so you can refer to it later in your notes. Okay, so some of the basic terms. Point. Okay, point is a location. Okay, a point has no size. I said that we're going to talk about the undefined terms. Point is our first undefined term, and I kind of like to think of it as it's referred to as an undefined term, and I like to reason that it's an undefined term because as soon as we make it or use it or draw it, we break its definition. Okay, so the definition of a point is a location that has no size. Okay, but we represent it with a small dot. Okay, and we name it as a capital letter. So here I have a point. Here we'll call it point D. Okay, just so we can refer to it, so I don't say, hey, look over there, and you don't know where I'm looking at. Look at point D. Okay, this is point D. If I'm writing it down, point D. See that here? Okay, but point D has a size. You see when I draw it, it has a size. It's a small dot. It's funny that the definition says a point has no size and it's represented by a small dot. Small means size. Okay, so there's kind of a contradiction in its definition, and it has to be with these terms that we'll start off with. Okay, so point. It's a small dot. It's a location. Okay, next we have a line. Okay, a line is a series of points that extends in two opposite directions. Yeah, I'll just say two. Add that there. In two opposite directions without end. Okay, you can name a line by any 2 points on the line. Okay, or a single lowercase letter. And so what we have here, let me get this down. We have a line. Okay, now, like I said, there are a series of points on this line, but I'm going to refer to point A and point B. Okay, we can find many more points on this line, but A and B here, point A, point B, and you see that I've also labeled this line L. Okay, when we name this line or refer to this line, here are a couple ways that we can do it. Again, we can use the points that are on the line, AB, line AB, okay, line BA. Okay, it doesn't matter which direction it goes because it extends forever in both directions. Okay, a line only extends in two directions. It has no thickness, and it continues on forever. So a couple things that we really can't do. We can't have a line, or we can't draw a line that continues on forever. When we draw a line, the arrows kind of symbolize that it keeps going. But a line has no thickness, just like a point or location doesn't, because it's made up of points and locations. But as we draw it, we have to give it thickness. So again, our definition kind of contradicts itself. In order for us to draw a line or use a line or work with a line, we have to contradict what a line is. Okay, another reason that's part of the undefined terms. Okay, while we're talking about lines, we're going to talk about the word collinear. Okay, collinear points. I have co underlined because I'd like for you to think of that root word. It means together. If you think of cooperate, collaborate, coagulate, cohabitate. Okay, co means together. Okay, so all those words cooperate, work together, operate together. I forgot the other ones that I said. Cooperate. Did I say cooperate already? Anyway, it means together. So if you just break down this word, together, line, on a line together. Points that are on a line together. Okay, or points that share a line. All right. So these are some terms you should be familiar with. And then our last undefined term, again, we're giving them definitions, but I like to call them undefined because their definition kind of contradicts what it is. In order for us to use it, we had to contradict what it is. A plane. Okay, so our undefined terms are what are commonly referred to as the undefined terms: points, lines, planes. A plane is a flat surface that has no thickness. Okay, a plane can be named by a capital letter. Okay, in this case, it's named plane P. Notice P doesn't refer to any point; it's just a capital letter. Or it can be named by 3 non-collinear points. Okay, again, non means not. So if you know what collinear points are, non-collinear just means not collinear. Okay. And now this is another undefined term because well, it's a flat surface that has no thickness. In order for us to draw it or write it or depict it any way that we can use it, we're going to have to give it thickness. Otherwise, it won't exist. It won't be tangible for us to use. Okay, it's best depicted in real life by like a piece of paper. If you can imagine the paper, instead of ending, here, extending on forever this way and this way. Okay, so a plane that goes on forever. There are a lot of planes. The ones that we are most likely to reference in the real life are like the walls of a room, the floor is a plane, the ceiling is a plane. We'll talk about some other planes that exist as we go through examples during these notes. Okay, again, remember that if you need to take time to pause so that you can write these definitions, do that. Okay. All right. So, finishing this off, got those down. Coplanar. Okay, again, together. Coplanar, together on a plane. Coplanar points are points that lie together on a plane. Or lines can be coplanar as well. Okay, things that lie on the same plane. Okay, so I try to depict a plane. This is just not a good cube. What's the trick? You can draw a cube, a square, and then you can do the corner thing and draw another square, and then you can connect those with lines. Connect here, and I'll try to do the dash thing. Okay, if you want to draw a cube. Okay, and those are used a lot. If I had done pencil, I could erase this so that you can see that this is supposed to be behind there. All right, so like I said, with the planes, we're used to seeing the floor or the ceiling as a plane. I'm going to name these just so I can refer to them a little bit easier. C, D, I'll call this E, F, G, H. Okay. Now, planes happen all over this cube, though. Okay, even though we can kind of picture the floor and the wall and the ceilings and stuff like that, this diagonal thing, okay, if I can try to shade it in, if you imagine that in the middle of that cube, EBCH, I'll use four letters to name it, even though I only need to use 3. Okay, but plane, I'll just use 3 now that I've said that. Plane EBC, notice that is a plane, even though it's not tangible. Planes have no thickness, so it's not like because it's a wall and you can see it, it makes it a plane. EBC is also a plane, or I could also name that EBH or EHC, any of those 3 letters that are on that plane. Okay, that's also a plane. So, things that you should remember from here: basic terms, points, lines, planes, and how to refer to them. a location or point is capital letter, single capital letter. You can name a line with the points, 2 points on the line, and a line symbol over top, making sure you have the arrows to show that it's a line that continues on forever, or just a lowercase letter. And then a plane, you can either name it with a letter that just labels the plane, or you can call this, I should have written this down, plane ABC. Okay, 3 non-collinear points. Okay, they can't lie on the same line. Okay, all right. So those are the basic terms of geometry. Moving on from there, we're going to talk about the basic postulates. Okay, now postulate, it's a word that we will use the most in this class, but if you do your own Google searches, you might run into the word axiom. Okay, and a postulate or an axiom is just an accepted statement of fact. Okay, something that you just accept without proof necessarily. But it makes sense to accept it. And one that I heard this year that kind of blew my mind, so I'll say it here, is the sun is hot. Okay. If I asked you if the sun was hot, you would say, yeah, it's really hot. If I asked you if you ever went to the sun to prove that it's hot, you'd say, well, no, I've never went to the sun to prove it's hot, but it's hot. Okay. And I'm not saying I disagree that the sun's hot. I'm just saying it's never been proven. You accept that the heat's coming from the sun and not something else that only happens when the sun's out. Okay, so a postulate is an accepted fact, and it makes sense to accept it. So you might think of it as something that is true, but you can't prove it's true. And we'll see a lot of postulate. Well, you can't prove it's true, but you should believe that it's true. Am I right on that? Maybe those words aren't good. But we'll look at some postulates and hopefully clear some of that up if there is confusion maybe. All right. So here's one postulate. It says through any 2 points there is exactly one line. Now here's the issue with this. There's no way that we're going to prove this point. Or there's no way that we're going to prove this postulate to be true. There's no way we're going to say this has to be matter-of-factly true. Because the only way to do that is to find every point and connect it with every other point. Now here's the issue. Can we find a point? Is there a way that we can actually connect a point with a line? No, because by the time we make a point, that point will have a size. Okay, and a point has no size. By the time we connect it with the line, well, that line will continue on forever and intersect with other points. Okay, and is there a way that we can find all of those things? No, there's no way that we can do that. Okay, but it makes sense that if I have 2 points, like I have on this sheet here, that I would be able to connect it with just one line. There's no way if I draw a point from A to B, if I can do that, A to B, okay, a straight line there. There's no other line that goes through A to B. Even if I went and did the ruler over there again, I just overlap that line. Okay, there's one line that goes through any 2 points. Okay. If 2 lines intersect, that's the first postulate. If 2 lines intersect, then they intersect in exactly 1 point. Think of a point as location again. Okay. So, and I should say any 2 lines. Okay. If any 2 lines intersect, they do so in exactly 1 point. Now, this is to remember this: lines are straight. They don't curve. They don't bend. Okay, they're straight lines. So, when they meet, they do it just once at 1 point if they meet. Okay, and that's here. Now you might think, well, what if they're the same line, like you saw in Algebra 1, where we had 2 lines that were, here and here, if we solved a system of equations, and then we said, oh, they're the same line, infinitely many solutions. Well, this is actually just the same line. It's not 2 lines. Okay, so this is just 1 line. But if we have any time where 2 lines intersect, they will intersect at a location at 1 point. Okay, I'll call this point like E. And I'll call this line M and line N. Okay, so line N and line M intersect at point E. Okay, there's no other intersection. There won't ever be an intersection. They'll continue on for this way and that way and that way and that way in their directions, but never meet again. Okay, on this plane. Okay, and then if two planes intersect, remember we can think of planes as walls and ceilings. They intersect in exactly one line. Okay, so I tried to do this drawing, but it looked kind of funky. It's supposed to be like a paper kind of thing this way, horizontally, and a paper vertically. Okay, if they intersect or went through each other, they'd intersect in a line. So here we have plane R and plane T intersect at line SW. Okay. Here I drew a cube, a little better of a cube. And you can see that when the walls intersect, they intersect at a line. So we have this plane ADH, this front wall, and this plane DCG, this side wall. When they intersect at DH, at line DH. Okay, so notice that this will be a practice in understanding kind of how to visualize three-dimensional objects on a two-dimensional paper. But those are the postulates that you need to accept, understand, know, and will use to build on. So again, what we learned in this first section, we learned the basic terms, points, lines, planes, okay? And then we learned the basic postulates. If there are any 2 points, there is exactly one line. Any 2 lines intersect, do so in 1 point. And when any 2 planes intersect, they intersect in the line. Okay. All right. And that's it. We will discuss. Well, that's it. We'll talk about rays and segments and parallel planes and lines in our next lesson.